So yesterday we looked at equations of the form like that. Now remember, we found the equal sign, which is right there. We identified which side the variable is on. Well, the variable appears twice, but both times on this left side. So what did we do with them? Yeah, we combine. Well, they're on the same side. If they're on the same side of the equation, we just combine them. Well, it's 5 and negative 2. So it's a 3x. Then we have the positive 7, so this equals 34. And then from there, what do we do to solve it? Subtract 7 from both sides, so 3x equals 27, and then divide by 3. X equals 9. And if we'd wanted to, we could put that 9 back in here for x and make sure we get the same value on each side. I'm going to trust that you guys can do that. I will tell you it'll work. But then we saw things like this. Not yet. So again, we found that equal sign. We have to identify where the variable is, and we see there's a variable appears on each side. In this case, we had to get rid of one. Got rid of the smaller one, which would be the 2x. So we're going to subtract 2x, make it go away. Leaves us with just the 13 there. But we have to subtract 2x from the other side. We can't take it away from the negative 5. We can only take it away from other x's. So subtract 2x from 5x to get 3x. And we still have the negative 5. Now we solve that by adding 5 because it's a negative 5. Good. So 18 equals 3x. And divide by 3. So 6 equals x in that equation. Well, today we're going to hit things that look like this. Of course, what looks different here is the parentheses. Anytime we see parentheses, it should scream at us. Do something here first. When we see those parentheses, we got to check two things. The first thing is there anything that needs to be done inside those parentheses? Well, inside the parentheses, I have 2x minus 7. Can I combine anything in there? No. Nothing I can do inside those parentheses. Second question is there anything that needs to be done to the parentheses? And here the parentheses are being multiplied by 8. So it's 8 times the 2x. So 8 times 2x is 16x. And 8 times negative 7 is negative 56. Now we have to solve that by doing what? Adding 56 because it's a minus 56. So on the left side, everything's gone but the 16x. 24 plus 56 is 80. Then what? Divide by the 16. So x equals 5. It's a good thing. So what am I going to do here? There's nothing to do in the parentheses, so I'm going to multiply by the 5. 5 times 5x is 25x. And then 5 times negative 11 is negative 55. Then what? Careful. Got to add the 55 first. So 75 equals 25x. And then divide by 25. So So 3 equals x. No, x equals 3, 3 equals x means the same thing. You can get a little bit more complex than that. When we do these problems like this one here, a lot of times get asked, why can't I just divide by 8? Cancel that out and get 2x makes 7 equals 3. Because 24 divided by 8 is 3. Well, in this equation, actually in both of these equations, I can do that and it'll work. Problem is, it doesn't always work. This is an example of that. I can't divide this by 5 because I got this 2x over here. So what I have to do is I have to distribute. Nothing to do inside that parentheses. So I have to multiply by the 5. 5 times 3x. 15x. 5 times 1 is 5. And I still got the positive 2x there. Now I'm going to combine what I can. I can combine 15x and 2x to make 17x. I have to remember that I still have the plus 5 there. So 17x plus 5 equals 56. Then what? Subtract 5. Very good. 17x equals 51, and then divide by 17. This equals 3. Looking at this one, very subtle problem here that makes it kind of difficult. There's nothing to do inside the parentheses. Everything needs to be done to the parentheses. It looks like there's nothing there, but there's a subtraction here, and we have to think of that as a minus 1. So we have the 2x up here, doesn't change. This is negative 1 times the parentheses. Negative 1 times 5x is negative 5x. Negative 1 times negative 1, positive 1. Very good. And now we have to combine 2x and negative 5x, negative 3x. Then what? Subtract 1. Negative 3x equals 15, and then divide by negative 3. Actually goes negative 5. Or we can get a touch more difficult. Just a little bit more difficult. Here there's things to do on both sides of the equation. So there's my equal sign. I'm going to start on the left side. Nothing to do in the parentheses, so I'm going to multiply by the 7. So 7 times 2x is 14x. Yep, 7 times 5 is 35. Still have the negative 4x there. What else can I do over here on the left side? I can combine 14x and negative 4x make 10x. And a positive 35. On the other side, yes, I can do the same thing. Nothing to do in the parentheses, so I'm going to multiply by the 5. 5 times 6x, 30x. 5 times negative 3, negative 15. I still have the positive 3. Over here, I gotta combine those. So the 30x doesn't change. Negative 15 plus 4, negative 11. So I've done whatever I can on each side. Now, I notice there's still an x on each side, so I have to get rid of one. The smaller one's the one I'm going to get rid of, which will be 10x. I subtract. I have to subtract 10x over there as well. Yeah, excuse me. So we got 35 equals 30 minus 10 is 20x minus 11. And then add 11. So 46 equals 20x. And divide by the 20. Now here, this is obviously not going to come out even. 2.3. Yeah. 46 divided by 20 is 2.3. Or you could look at it like this. 46 divided by 20 is 46 over 20. That is 2 and 6/20ths, reducing the fraction. And then that's 2 and 3/10. So either do 2.3 or just 2 and 3/10. Either one's an acceptable answer there. In your book, page 253, exercise 6.3, 1 through 59, the odds are equations with these parentheses in them. Loads of fun.